Hello again, you lot. Welcome back to learning about chemistry. Really quick one today because it's not very big. We're going to look at chromatography. That actually comes under this section of the syllabus here, criteria of purity. So chromatography is a way of separating stuff and looking at purity. Here is the syllabus points for that. It is 2.2.1. So we're going to look at chromatography. I think the best way to do this is to look at the example and to look at the kinds of things that you always get asked about. Okay, so I'm going to put up a picture. You get to see my lovely artwork of some chromatography, and we'll talk about that. Then we'll go over a question. So here is my my picture of a chromatogram. All this is, chromatography is very simply a way of separating things that are dissolved. So what we've got is we've got chromatography paper or filter paper. I'm sure you'll all have given this a go in your classrooms. So this is filter paper. You'll have to excuse me, I'm writing with a mouse. So we've got filter paper. This here is just a beaker. And at the bottom here, we will have some solvent. So solvent is anything which is going to dissolve the substances that we're trying to test. And the solvent can be water, it can be an organic solvent, anything like that. All right, so this is how you set up your chromatography experiment. You take your filter paper and you dip it into some solvent. But what are we testing? Well, we need a mixture of things. It's usually done with colored dyes. So things you got to remember, you need to draw a line on the chromatography paper, and it must be with a pencil. Okay, it has to be with a pencil. That is because if it was ink, the ink would dissolve in the water. So some points to remember. Always draw the chromatography baseline, which is what that is called, with a pencil. That is a marking point that you will lose marks on if you don't do it correctly. So this is called the baseline. And the baseline is where you put your mixture. So that is usually a sample of whatever you're testing. So you'll put a spot of it on there like that. And again, I'll put that down. So place the sample to be tested on the baseline. Now, a really common mistake that I see people making is saying that this liquid at the bottom is the sample that's being tested. It's not. That's the solvent. The sample is separate and on the baseline. It has to be absorbed into the paper before you start. So that is the sample. Now, the sample is a mixture of various things. So another thing to notice is that when you put the chromatography paper into the liquid, the baseline must be above the level of the solvent. Okay? And that is because if it wasn't, it would all just dissolve into the solvent and it wouldn't do anything. So what's going to happen is the solvent is going to absorb into the filter paper. Over time, it is going to rise up the filter paper and it will travel a certain distance. And the distance that the solvent travels once the chromatography experiment is over is called the solvent front. Okay? That is the solvent front. And if you've done it correctly, then what should happen is your sample should have separated into several dots. On the exam paper, they are usually drawn as dots. If you do them in a real experiment, you will see that they are in fact more like smudges. I'll just put a few different colors on here. So these are your samples that you're testing here. Now, the main thing, or the first thing that you can do with chromatography, is see how many other compounds were in the mixture that you've just done. So the number of spots, not counting the original, is the number of compounds in the original mixture. So in this example that I've drawn here, we have got a total of 3 compounds. So in this experiment, I can say that my original red ink was made of 3 separate mixtures. Okay, so that's the first thing that you can do. You can find the number of spots, and that'll tell you how many compounds were in the original mixture. So the next thing that you can do is you can use chromatography to identify things, because what this does, so to identify unknown substances, so what this does is certain compounds will travel a certain distance, and they'll always travel the same distance. So this orange one, for example, will always travel that distance, whatever that might be. So to identify unknown substances, what you need to do is you need to place a sample of the known compound and compare distance traveled. So what that would look like, if we did another chromatogram, so let's say we did this one here on wider paper, and I've got my baseline, so I'll use the same colors from before. So let's say that I did this with my red ink and I ended up with orange, yellow, and blue spots. So then what I did is I say, okay, I want to know if this orange is the same as this other orange that I've got. I would test the orange there, and I want to know if the yellow is the same. So I take a sample of my known yellow and my known blue, and then I see what happens. So let's say I got these results. Okay, let's say I got these results here. Then what this would tell me is that the orange dye that I use here is the same as the orange dye that was in the red mixture. Now how do I know? Because it's traveled the same distance. The yellow dye is the same as the yellow dye that was in the mixture because it's traveled the same distance, but the blue dye is not the same as the blue dye that was in the mixture. Even though they're both blue, they're different chemicals. So that means it has traveled a different distance, they're not the same. We can put numbers on this and be a bit more specific. The reason we would need to do that is because if you change the temperature or do these at different times or things like that, then you would get a different distance traveled. So what we can work out is you can work out something called the retention factor, which is also called the RF value. And the RF value is the distance traveled by the sample, and I'll label that on the diagram in a minute, divided by the distance traveled by the solvent. Okay? So if I wanted to know, for example, the RF value of this orange spot, what I would do is I would measure from the baseline to that orange spot there, and then I would measure from the baseline to the solvent front there. That's meant to be a straight line, but it's not, sorry. And I would divide one by the other. Because the solvent is always going to travel further than the sample, then we always know that the RF value will be less than 1. So that means if your RF value is more than 1, you've done it the wrong way around. And what's the RF value used for? Well, you can use the RF value to compare the distances traveled and therefore identify it, because if two things have the same RF value, they are the same substance. So I'll put that down. If two things have the same RF value, they are the same chemical. Okay? And just to kind of sum up chromatography, chromatography is a way of separating dissolved substances or soluble substances by their solubility. Alright, so let's take a little look at how that might be asked in a question. So we've got a question here about chromatography. Some grass is crushed and mixed with the solvent propanone, so the solvent doesn't always have to be water. The color pigments are extracted to give a deep green solution. Draw a label diagram to describe how you ensure there is more than one colored pigment in the green solution. So this is, you'll draw the chromatography thing from what we saw on the previous slide, but the marks would be for things like making sure that your baseline is above the level of the solution. That would be one mark. Okay. Now it's also shown how there is more than one colored pigment. Okay, so you're going to have more than one colored pigment. That would be another mark. Okay, and that's 3 marks. The other one would be for making sure everything was set up correctly. So having your filter paper and things like this. The second part here is what I was talking about at the end of the last slide. Given a pure sample of chlorophyll, how could you show the green solution from the grass contained chlorophyll? So what you would do is you would do this chromatogram, this chromatography experiment, and you would do another experiment. So, you know what, I'm going to type. So you would, how can I type? You would run the chromatogram, which is what this is called, with pure chlorophyll, and then you would compare to the original, and if it is chlorophyll, they would travel the same distance. Or the alternative to that, hopefully you remember from 2 minutes ago, is to calculate the RF value and compare. But you need that idea of comparing to get the mark for this one here. Okay. And the final marking point for chromatography is that sometimes the separated substances are not visible to the human eye. So you have to put something on them to make them visible. Now, if we look at the syllabus, we don't need to know specifically what those chemicals are. We just need to know that they're called locating agents. So locating agents are the ones that make invisible things visible. So you might have to put in an exam, you have to add a locating agent. So as we can see, here's the syllabus points. Quite a short topic, chromatography. Hopefully you've had a chance to try some out at school or in a lab. Take a look at the marking points here. And again, thanks for watching. New video next time. Thanks for watching again. Good luck with chemistry.